Okay, today we discuss about covalent bond. Okay, so after the completion of the ionic bond, we are going to discuss covalent bond. So, what is the covalent bond? Who proposed this means? So, it was introduced by at first it was proposed by Lewis. Okay, so actually Lewis, the ionic bond was proposed by Coastal. So in both theories means in the Lewis theory the formation of covalent bond, in the Coastal's concept formation of ionic bond. Both bond formations gives the importance for octet rule. Means in both bond formations, in both concepts, octet rule is important. Octet rule means getting of 8 electrons, in their valency to get a stable gas configuration, nothing but stable electronic configuration. So in ionic bond formation, what happened? Some atoms loses their electrons and become positive ions. Some atoms gains electrons from others and become negative ions. So as a formation of cation or the formation of anion, the final target, the final aim is to get the octet configuration in their valency and become stable by gaining nearest to noble gas configuration. So in the ionic bond formation, the formation of anion, the formation of cation is to get the octet configuration. If that transfer of electrons is not possible, means losing electron not possible, gaining electron is not possible. Okay, there is an alternate bond, there is an alternate concept is there, that is called covalent bond. So according to Lewis, covalent bond is formed, nothing but octet configuration is obtained by sharing their valency electrons Okay, there is one of the chances to get the octet configuration. Like gaining losing ఏ కాకుండా ఇంకో ఛాన్స్ ఏంటంటే to get the octet configuration given by Lewis is the octet configuration is obtained by sharing their valency electrons for atoms. Okay. Okay. So according to Lewis, octet configuration can be obtained by sharing the valence electrons for atoms. Okay. So now we see the definition and other example for covalent bond. So we can define the covalent bond that the bond formed by sharing of same number of electrons. The bond formed by sharing of same number of electrons by two atoms. The bond formed by sharing of same number of electrons by two atoms is called covalent bond. Here important point. So between the similar atoms or it may be different atoms. Okay. So the bond formed by sharing the same number of electrons. Same number of electron means, for example, there is a bond formed between A and B. If A donates one electron, B also donates one electron. And that electrons are mutually shared by both atoms. Okay. The bond formed by sharing of same number of electrons by two atoms is called covalent bond. And here the point, the shared electrons are so under the attraction of nucleus of two atoms. Okay. The shared electrons are under the attractions of nucleus of two bonded atoms. Okay. And ఇక్కడ షేర్ చేసుకున్న electrons they're exactly under the attraction of two nucleus. Okay. For example, A donates one electron, B donates an electron. Now these two electrons are under the attraction of A, and these also under the attraction of B. That is called mutual sharing. Okay. As covalent bond is denoted with a line, denoted by a line like this. Okay. The number of bonds covalent bonds formed between atoms is equal to the number of electrons shared by them. Okay, so if the number of pair of electrons, it is equal to the number of pair of electrons shared by them. So if, for example, between, again we are taking A and B, you can take A and A, B and B, A and B, anything. A donate one electron, B donate one electron. Mean how many electron pairs are shared? One number of pair is shared. So there is a formation of one bond. If they donate, A donates 2 electrons, B donates 2 electrons, and if they shared by both atoms, here 2 pairs are shared by both atoms, there is a formation of a double covalent bond is formed. Next, if 3 pairs are shared, if 3 electrons pairs are shared between the two atoms, they are under the attraction of two nucleus, they present exactly middle of the two nucleus. Two nucleus ki exact majlo untai. and number of pair of electrons shared. Here we said the number of covalent bonds formed between atoms is equal to the number of pair of electrons shared by them. Here 3 pair of electrons shared means there is a formation of triple bond takes place. So according to this covalent bond theory, maximum number of bonds between the two atoms is 3. Okay, means the single line is called single bond, double line is called double bond. Here 3 lines is called triple bond. So this maximum number of bonds between the two atoms is only 3. Between the two atoms, not by an atom, between the two atoms. Okay, for example, A ki B ki maximum 3 bonds ఉండొచ్చు. A can form other bond with C. Other B తో ఇంకో bond form చేయొచ్చు. Okay, so a total number of bonds of A, it depends on its nature. Okay, there is no limit. Okay, but between two atoms there is only 3 bonds are possible according to this concept. Okay, so the maximum number of bonds, the maximum number of covalent bonds between two atoms is 3. Means between two atoms, triple bond is the highest one. Okay. So what happened? The sharing of electrons. So sharing of electrons, they will get their nearest noble gas configuration. So ఎందుకు షేర్ చేసుకుంటా electrons అంటే starting చెప్పాం మనం. So that is only to get the 8 electrons in their valency shell. Okay. Now we see the formation of some examples. Here see this double bond. Triple bond are separately known as multiple bonds. Okay, multiple bond means it may be double bond or it may be triple bond. Okay, now we see the formation of some molecules as examples. And examples are important. The first one, the formation of H2 molecule. Okay, the formation of H2 molecule. So what is the hydrogen configuration? We know that 1s1. So like the 2 hydrogens are there, 1s1. Now both hydrogens need one electron to get a octet configuration. So this is the one hydrogen position. So this is second hydrogen position. So it need one electron, it need one electron. For example, in the formation of NaCl, Na wants to lose one electron, Cl wants to gain one electron. కాబట్టి అక్కడ పర్ఫెక్ట్ గా మ్యాచ్ అయింది, వన్ గెయినింగ్ వన్ లూజింగ్. సో అక్కడ ట్రాన్స్ఫర్ ఆఫ్ ఎలక్ట్రాన్ పాసిబుల్ అవుతుంది. బట్ హియర్ హైడ్రోజన్ ఆల్సో వాంట్ వన్ ఎలక్ట్రాన్. సో బోత్ హైడ్రోజన్స్ ఆల్సో want one electrons. Okay, so at that time it donates its electron, it also donates its valency electrons, and now that both electrons are shared by both atoms. Now this hydrogen is having 2 electrons. This hydrogen is also having 2 electrons. Now both are having 2 electrons with the helium configuration. So one pair of electrons shared, that is can be written as H-H. Okay. So this electron position can be written as, it is the total our choice. So you have to provide it. Okay, means here hydrogen gains which configuration? Helium configuration. Now see the second example. Formation of chlorine. Okay, formation of chlorine molecules. What is the chlorine configuration? (17) 3p5. So what is it's same. The other CL is also having same configuration. Now both are having 7 electrons in their valency. Sorry. Both need 1 electrons to get the octet configuration in its valency. Nothing but near argon configuration. Okay, argon configuration ki ravadaniki both chlorines need 1 electron. So now we are representing the electron model. Both CLC but both electrons same ga identify chedam. It is having 7 electrons. 1, 2, 3, 4, 5, 6. So write this 7. Others here also having 7 valency electrons. 1, 2, 3, 4, 5, 6, 7. Now this need 1 more electron. This need 1 more electron. So if any electrons required, any electrons donate cheyali. Donate cheyalante for any electrons contribute cheyali for sharing. Okay, అంటే ఇక్కడ పర్మనెంట్ గా లాస్ అవ్వట్లే, పర్మనెంట్ నో పర్మనెంట్ గెయినింగ్ అండ్ నో పర్మనెంట్ లూజింగ్. సో ఇట్ నీడ్ 1, ఇట్ మస్ట్ కాంట్రిబ్యూట్ 1. ఓకే, ఇది 1 కాంట్రిబ్యూట్ చేసి అదర్ 1 కాంట్రిబ్యూట్ 1 and they can share that electron according to this concept. This shares this 1 electron, this also shares this 1 electron. Okay. So in that middle electrons, one is the first chlorine, other is the second chlorine. Now these shared by first chlorine and also shared by second chlorine. Now this chlorine having how many valence electrons? 1, 2, 3, 4, 5, 6, 7, 8. It is also having 8 electrons. Now both chlorines are in which stage? In octet configuration with argon configuration. Both become stable. So now how many bonds are formed between 2 chlorines? The sharing of electrons only 1 carbon. There is a 1 bond is formed between them. So what about remaining electrons? Remaining electrons are not used in the bond formation, are called lone pair of electrons. Here hydrogen lo there is no lone pairs, but in the chlorine lo there is 3 lone pairs on each chlorine. Okay, so now see the other example. Formation of HCl. Here 2 different atoms. Hydrogen 1s1 need 1 electron. This need 1 electron. This also need 1 electron. So here hydrogen having this one electron. సో ఇక్కడ క్రాస్ మార్క్ ఎందుకంటే ఇక్కడ టూ డిఫరెంట్ ఆటమ్స్. సో ఇప్పటిదాకా మనం చెప్పిన దాంట్లో సేమ్ ఆటమ్ HH సేమ్ సింబల్ రాసాం ఫర్ ఎలక్ట్రాన్ కి. Cl సేమ్ ఆటమ్స్ కాబట్టి we use the same symbol for electrons. Here we are taking two different atoms. That's why we are taking different symbol for electrons of different atoms. H కి క్రాస్ తీసుకుందాం, మిగతా వాటికి డాట్ తీసుకుందాం. Cl7 1 2 3 4 5 6 7. It need one electron, it need one electron. So both donates their one electrons. Yes, and sharing that electrons. Hydrogen gets helium configuration, chlorine get neon configuration. Okay, so try to write the same size. Okay, means what is the how many bonds here? H bond, Cl. Okay, so in this example what is the difference? So the difference is here covalent bond is formed between two dissimilar atoms. ఇక్కడ similar atoms. ఇక్కడ here both similar atoms kabatti both gain a same type of configuration, that is both are in helium configuration. Here both are in argon configuration, but here hydrogen in helium configuration whereas chlorine in argon configuration. Okay, now we see the another example. You must have to write the total things. Okay, so malli after opening up the schools, so malli ivanni revise cheyadam maybe it is not possible. Okay, so ఇప్పుడు మీరు పర్ఫెక్ట్గా నోట్స్ రాస్తేనే ఇట్ బికమ్స్ వెరీ ఈజీ. అప్పుడు ఏమైనా డౌట్స్ క్లారిఫై అంతే కానీ డీటెయిల్ ఎక్స్ప్లెనేషన్ ఈజ్ నాట్ ఎట్ ఆల్ పాసిబుల్. Let's see the other example. Formation of methane. Here also between two dissimilar atoms, total 5 atoms. What is carbon? 1s2 2p2. There is 4 electrons. Again it need 4 electrons. It again need 4 electrons. Hydrogen 1s1. How many hydrogens are there? 4 hydrogens are there. Okay, now these 4 hydrogens need one electron, but this carbon need 4 electrons. By mutual understanding, the carbon shares its 4 electrons with 4 different carbon atoms, 4 different hydrogen atoms. So here the important thing is, so in this bond formation we want to write a sentence that one carbon atom shares its electrons 4 valency electrons with 4 different hydrogen atoms. Here one carbon atom shares its 4 valency electrons with 4 different hydrogen atoms. Okay, now this carbon is having 4 valence electrons. 1, 2, 3, 4. So మనం డ్రా చేయడానికి పర్ఫెక్ట్గా ఏదైతే అవైలబుల్ ఉంటుందో ఈజీగా ఉంటుందో ఆ షేప్లో రాస్తాం. బికాస్ ఇప్పుడు అకార్డింగ్ టు లూయిస్ మనం చెప్పేది కోవలెంట్ బాండ్ ఎక్స్ప్లెనేషన్ టోటలీ అబౌట్ గివెన్ బై లూయిస్ కాన్సెప్ట్. లూయిస్ కాన్సెప్ట్ బేస్ చేసుకుని మనం కోవలెంట్ బాండ్ ఫార్మేషన్ చెప్తున్నాం. దీంట్లో కోవలెంట్ బాండ్ ఫార్మేషన్ బై లూయిస్ డస్ నాట్ ఎక్స్ప్లెయిన్ ద షేప్ ఆఫ్ ద మాలిక్యూల్స్. కాబట్టి ఇక్కడ పర్ఫెక్ట్ షేప్ గురించి మనకి డీటెయిల్స్ ఉండదు. ఓన్లీ షేరింగ్ ఆఫ్ ఎలక్ట్రాన్స్ criteria. Now what about hydrogens? Hydrogen are having 1 electron each. Okay, now each hydrogen provides 1 electron and this carbon provides 1 electron to all hydrogen atoms. Now see, this hydrogen is satisfied by getting helium configuration. This is satisfied, this is satisfied, and here 4 hydrogens are satisfied with the 2 electron, that is helium configuration. Now what about this carbon? Now the carbon is also satisfied with how many electrons? 8 electrons in its valence shell. So there is a 4 bonds are formed by carbon with different hydrogen atoms, and carbon getting neon configuration, hydrogens get helium configuration. Okay, so ఇక్కడ cross marks dots ఏంటంటే both represents electrons only. But in 2 marks ఏంటంటే మనకి cross marks for hydrogen, dots for carbon, just for our convenience. Let's see some examples in double bonds. Okay, formation of dioxygen. Formation of dioxygen. You must know the configuration. Without knowing configuration, it is very poor to get this covalent bond. It need how many electrons? 6 electrons. Again it need 2 electrons. So other oxygen also having same condition. So one or both oxygens need 2 electrons. So ఇప్పుడు ఇక్కడ ఇంపార్టెంట్ ఏంటంటే ఒక ఆటమ్ కి ఎన్ని ఎలక్ట్రాన్స్ రిక్వైర్డ్ అన్ని ఎలక్ట్రాన్స్ కాంట్రిబ్యూట్ చేస్తుంది కంపల్సరీ. దెన్ ఓన్లీ ఇట్ ఈస్ ఎక్స్పెక్టింగ్ ద సేమ్ విత్ అదర్ ఆటమ్. ఇప్పుడు ఈ ఆక్సిజన్ 2 అవసరం కాబట్టి ఇది 2 డొనేట్ చేస్తే ఇది ఇంకొక 2నే డొనేట్ చేస్తుంది. ఓకే, మ్యూచువల్ అండర్స్టాండింగ్, దట్స్ వై ఇట్ ఈస్ కాల్డ్ షేరింగ్. ఫర్ ఎగ్జాంపుల్ బోత్ ఆక్సిజన్స్ కాబట్టి నార్మల్గా రాసేద్దాం ఎలక్ట్రాన్స్. ఆక్సిజన్ 6 electrons, 1 2 3 4 5 6. Other oxygen 1 2 3 4 5 6. It need 2 electrons, it need 2 electrons. It provides the 2 electrons to it. It also provides 2 electrons to it. Now that provided electrons, the provided electrons by both atoms shared by both. Okay, now both got the octet neon configuration. There is a formation of double bond. Okay, this is formation of O2. And next See the formation of N2. What is the N2's configuration? Like this. In valence it has 5 electrons. Only highest shell మనం valency అంటాం కదా. It need other 3 electrons. Same other nitrogen also need 5 electrons. Sorry, having 5 electrons need 3 electrons. 3 electrons need కాబట్టి each one must contribute 3 electrons. 1, 2, 3, 4, 5 of one nitrogen. 1, 2, 3, 4, 5 of other nitrogen. So both shares that electrons. So ikkada position lo ee pair me right side rayala, upper lo rayala, downwards rayala, that is totally your choice. There is no specific conditions writing this position of electrons. Okay, now both gain neon configuration. Now there is a formation of triple bond having lone pairs on each nitrogen atom. Okay, this is formation of a triple bond. Next we see other. See the formation of water. Okay, total 3 atoms are there. The hydrogen, 2 hydrogens condition, 1s1, 1s1. So what about oxygen? We know valency 6 electrons. It need 2 electrons. 2 hydrogen also need 2 electrons. So here we are not discussing about the shape. Only can my target in the day sharing of electrons number important. This hydrogen have 1 electron. This oxygen have 6 electrons. That is 1, 2, 3, 4, 5, 6. This మన content base చేసుకొని electron రాస్తున్నాం. Okay. Now hydrogen provides 1 electron. This hydrogen provides 1 electron. Oxygen also provides 1 electron. Now this hydrogen is satisfied. This hydrogen is satisfied. Now this oxygen also satisfied with 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, so now there is 2 different bonds and 2 lone pairs on oxygen, no lone pairs on hydrogen. Okay. సో ఇక్కడ మనం యాక్చువల్గా ఒరిజినల్ షేప్ ఆఫ్ H2O ఇది కాదు, జస్ట్ ఇక్కడ బాండ్ ఫార్మేషన్ మాత్రమే డిస్కస్ చేస్తున్నాం మనం. ఓకే, ఈ షేప్స్ అనేవి మనకి నెక్స్ట్ థియరీలో వస్తాయి. నెక్స్ట్ we took some other examples. So you have to understand the concept perfectly by taking the diagrams. Maybe the next one we can write see the formation of ammonia. Here nitrogen, it needs 3 electrons. And what about 3 hydrogens? 3 need 1 electron. This need total 3 electrons. So nitrogen having 5 valency electrons, and it shares its 3 valency electrons with 3 different hydrogen atoms. Now, so the bond will be like this. So 3 bonds. Helium configuration. Helium. This is neon configurations. All are satisfied with the nearest noble gas configuration. Okay. So this is the formation of covalent bond with some different examples. Here at last I want to give a definition that is known as covalency. Important one, covalency. So what do you mean by covalency means? Already we discussed in the ionic bond, that is electrovalency. So electrovalency ante in the ionic bond formation lo the number of electrons gained or loosed by an atom in the formation of ionic bond, and in the formation of ionic bond lo how many electrons loosed or how many electrons gained by one atom, then electrovalency. Same here, the number of electrons shared by an atom, the number of electrons shared by an atom to get near noble gas configuration. For example, hydrogen gains, so how many it shared how many electrons? 1 electron. Hydrogen covalency is 1. Here what about nitrogen covalency? Nitrogen shared how many electrons? 1, 2, 3 shared electrons. So it shared 3 electrons, its covalency is 3. Okay, so we can write the definition like this. The number of electrons contributed by an atom Okay, see the covalency means the number of electrons contributed by an atom of an element for sharing with other atoms to get nearest noble gas configuration is called its covalency in the molecule. అంటే ఒక మాలిక్యూల్ ఫామ్ చేయడానికి ఒక ఆటమ్, ఒక ఎలిమెంట్కి సంబంధించిన ఆటమ్ ఎన్ని ఎలక్ట్రాన్స్ షేర్ చేసుకుంది, ఎన్ని ఎలక్ట్రాన్స్ ప్రొవైడ్ చేసింది, దట్ ఈస్ కాల్డ్ ఇట్స్ కోవాలెన్సీ. ఆర్ సింప్లీ వీ కెన్ సే the number of covalent bonds formed by the atom of the element in that molecule formation is called its covalency in it. Okay, say number of electrons contributed, nothing but number of bonds formed is equal. Okay, this is about the covalent bond and covalent bond formation of some molecules. So tomorrow we see the other topic of covalent bonds or covalent molecules. Okay.